You see the path difference between two extreme rays is x is equal to a sin theta. Then phase difference is equal to 2 pi by lambda into path difference, that is 2 pi by lambda into a sin theta, and this quantity we say is 2 alpha. In the theory, where alpha is the pi by lambda, that is half of this pi by lambda a sin theta, and that is the this formula is derived in a complicated manner. Of course, that is not required, only we will quote the final result. Then we come to the first case. First case is, we see from the intensity pattern that there is principal maximum, there is secondary maximum, like that. So, first let us write principal maximum. There is one maximum. So, when alpha tends to 0, sin alpha by alpha tends to 1. This is a mathematically established fact that sin theta is by theta, when theta tends to 0 is 1. So, I theta is equal to I 0, that is maximum. So, I 0 here means the intensity of the principal maximum, and when it will be possible, when alpha tends to 0. So, alpha is equal to 0 is equal to pi by lambda into a sin theta. So, here a is not 0, pi is not 0, lambda is not 0. So, theta is equal to 0 degree. That means, the principal maximum is formed by those waves which are moving horizontally, making 0 degree with the horizontal direction. So, that is the idea of principal maximum. Then we come to the minima. Minima means plural, many minima are present. So, we come to the minima. Minima are dark points where intensity is 0. D1, D2, D3, etc. they are present on either side of the principal maximum. So, we come to the second one. For second one, we say it minima. Minima means dark spots on the screen. So, there I theta is equal to 0. So, I theta must be 0. We demand that for dark spots I theta will be 0 is equal to I 0 sin square alpha by alpha square. But I 0 is not 0. So, therefore, sin alpha must be 0. We cannot say that sin alpha by alpha will be 0, because that is 1 actually maximum. So, that implies sin alpha is equal to 0. So, this is possible when alpha is equal to say k pi, plus minus also can be given, where k is a constant, k is a number, k is equal to 1, 2, 3, like that. We cannot say 0, 1, 2, 3, because if you say k is equal to 0, then this will correspond to principal maximum case. So, principal maximum case will have 0. So, that is avoided by taking 1, 2, 3. So, that means pi by lambda a sin theta is equal to plus minus k pi. So, a sin theta is equal to plus minus k lambda. So, this is the condition for dark points. For the first dark point, as you see D1, here it will be k is equal to 1. So, it will be a sin theta 1 is equal to lambda. For the second dark spot, it will be A sin theta 2 is equal to plus minus 2 lambda. So, like that. So, this is the condition for minima. Then we come to the condition for secondary maxima. Secondary maxima are B1, B2 present on either side of the principal maximum. So, third is your secondary maxima. So, here what will be the condition? We cannot say that I theta is maximum, because I theta maximum will give to complicated things. That is possible, but in that way we will not do. We will do it in a simpler way, because from the diagram we can see that B1 is present approximately in between D1 and D2. That means, the value of alpha for B1 will be average of alpha 1 and alpha 2. So, you see B1 is present in between alpha 1 and alpha 2, alpha and alpha 2. So, we can say alpha for B1 is equal to alpha 1 plus alpha 2 by 2. That means 1 pi, alpha is k pi. So, 1 pi plus 2 pi by 2, that is 3 pi by 2. So, alpha value for B1 is found. So, I1 is equal to intensity of B1 is obtained from this formula is equal to I0 sin square 3 pi by 2 by 3 pi by 2 whole square. The top one is sin 270 degree whole square. Sin 270 degree whole square is 1, then that is 3 pi by 2. So, it is I0, then 4 by 9 pi square. That is nearly equal to I0, it is a 81 almost. So, 4 you divide is nearly equal to I0 by 21, that is 0.045 I0, that is 4.5% of I0. That means, we see that the secondary maxima have a little intensity compared to the principal maximum. Principal maximum has much higher intensity compared to B1. Similarly, you can do for alpha for B2 as between D2 and D3 and proceed in the same way to get the intensity, that is 1 point some percent, and then the third one is at 0.83% of I0. So, in the same way we see that after a few of them others are not visible to our eyes, because the intensity reduces to a great extent. So, this explains the diffraction due to a single slit. Then we come to another phenomenon observed by the light, which can only be explained with the help of wave nature of light. And in addition to wave nature, the light wave must be transverse, then only this can be explained. So, that phenomenon is called polarization of light, and our eyes are unable to distinguish between this unpolarized light and polarized light. So, for that we need some other devices, and this we have discussed while doing the electromagnetic waves. So, there the vibrations, these are electric vectors and magnetic vectors. So, they can be anywhere and they are arbitrary. So, this is plane of vibration. Suppose direction of propagation is your say z axis, then this will be xy plane. That means ordinary light is like this. Ordinary light they have vibrations in all possible directions in a plane. There are crystals so, this phenomenon is called polarization, and tourmaline or Polaroid. Tourmaline is a naturally occurring crystal and Polaroid is an artificially prepared device to test the light which is polarized or not. So, tourmaline or Polaroid can be used to know whether light is polarized or not. Polarized means the vibrations will be in one specific direction. Suppose you take this is unpolarized light. Unpolarized light, and we introduce this crystal. This is called the polarizer. So, polarizer is a hexagonal crystal having one axis of symmetry. This is called axis of symmetry. Then what happens? It is found that when light passes through the tourmaline crystal or a Polaroid, only this type of vibration is allowed to pass. That means the vibrations which are parallel to the axis of symmetry are allowed to pass. And what happens to the other vibrations? They are absorbed by the crystal. They are not allowed to pass. So, this is called polarization. And if another crystal parallel to that will be kept, this is the axis of symmetry. So, this is called the analyzer. So, here you again get polarized light, because the two axes are parallel to each other and the vibration easily passes through the crystal. So, if we do the same experiment again, this is unpolarized light, then again up to this they are same. The polarizer, that is polarized light produced. Then if the analyzer will be rotated about the axis, if it is rotated, analyzer in crossed position, say crossed position means they make 90 degree. Suppose this is the that makes 90 degree. Then here we find no light, that is called crossed position. So, this is your polarizer, this is analyzer, and this is polarized light. So, polarized light when passes through a tourmaline crystal or Polaroid kept 90 degree to the horizontal direction, they are called cross position, and no light is received. So, our ordinary eye can also locate this one, that no light is there. So, this is one experiment by which we can know whether the light is polarized or not. This is unpolarized light, this is polarized. So, polarized light when passes through a crystal like tourmaline or Polaroid may give rise to light or may not give. But ordinary light when passed through tourmaline in any position will show some light, because the axis of symmetry will allow some vibration to pass. But this polarized light cannot do that. So, that is the experiment. Then we come to Marlowe's law. The scientist Marlowe, what he did, he introduced polarized light. Polarized light of intensity I0. So, is passed through a crystal, or Polaroid. Crystal means tourmaline crystal or Polaroid. Then it is found that the passed through a crystal or Polaroid being rotated from 0 degree to 360 degree. That means over a complete rotation they are rotated. This analyzer is rotated. Then what is observed? They observed that for two positions there is maximum light, and for two other positions there is no light, and in between there is some light. So, he gave the formula I is equal to I0 cos square theta. So, this is your Malus law. That means when theta is equal to 0 degree or 180 degree, comma, I is equal to maximum, that is I0. Theta is equal to 90 degree or 270 degree, I is equal to 0 is equal to minimum. Then for theta less than 90 degree, I is finite, not equal 0. So, this is your Malus law. That means Malus law explains the observed fact that it is possible to have no light, it is possible to have some amount of light or maximum light. So, that explains the experimentally observed fact. Then we come to how to produce polarized light. One method is we have shown that passing through a crystal like tourmaline or Polaroid, one can produce polarized light. There are other methods by which polarized light can be obtained, and those methods are very interesting in the sense that they give rise to a formula called Brewster's law. So, polarized light can be produced by number 1 reflection, number 2 refraction, number 3 scattering, number 4 absorption. So, these are the methods. So, let us discuss refraction, polarization by reflection. Suppose you have a plane mirror, there is incident light. Suppose it is unpolarized. Unpolarized light is incident. This unpolarized is represented by this symbol. Unpolarized light is represented by this symbol. So, when this is incident, the angle of incidence made with the normal can be changed. So, this angle of incidence is IP, that is polarization angle. If it is 57 degree, then the reflected light is found to consist of the vibrations that are perpendicular to the perpendicular into the plane, and that is polarized. So, unpolarized light, incident light is unpolarized, whereas reflected light is polarized. That can be tested with the help of tourmaline crystal. Then suppose you take a glass slab or say any other material slab, transparent. So, if light is incident, what happens? A part is reflected and a part is transmitted. So, it is found that when this is unpolarized, light is incident, and as you know, there is a reflected light which is completely polarized for 57 degree, which is called IP, and at that time it is found that this is angle of refraction RP, and this consists of both dot and arrow, because part is reflected. Reflected light is completely polarized, but a part is reflected, so the other part is with it. So, this is refracted ray. Brewster observed that angle between reflected and refracted rays is 90 degree. For this situation, is this is polarized. Reflected light is perfectly polarized. Under this condition also he observed this angle to be 90 degree. That means unpolarized light incident at 57 degree. Then question is, why it is always said 57 degree? Why not any other angle? Why not any other angle? So, here you see that this whole angle is, so IP plus 90 degree plus RP is 180 degree. So, that implies RP is equal to 90 degree minus IP. So, if you write, then Snell's law gives sin IP by sin RP is equal to refractance of glass with respect to air, and it is now sin IP by NIP is equal to mu of glass with respect to air. So, this is called Brewster's law. So, by this one can find the angle of polarization, and there is a explanation of reflection and diffraction from wave theory, which could not be done due to shortage of time. So, that one has to read, that is all.